Hello everyone, welcome to my channel Physics with Bhatt. To learn concepts of physics, subscribe this channel and press the bell icon button to notified of every new video lecture. Hello everyone, today once again I am with you. In the last video lecture we discussed about the concept of coherent and incoherent sources, interference of light in brief, and in the end we were talking about the types of interference. I just recapitulate or try to recall everything about the interference of light. You can see the text shown here also. When two waves of same frequency or wavelength and of constant phase difference propagating along same direction superpose each other, then interference occurs. The interference is of two types, constructive and destructive. In today's video lecture, we will discuss in detail that under what condition the interference is constructive and under what condition the interference is destructive. So, we have to take two waves for the purpose to understand the concept of constructive and destructive interference. So, let two waves y1 is equal to a1 sine omega t and y2 is equal to a2 sine omega t plus phi superpose each other. Then the resultant wave y is equal to y1 plus y2. If you replace for both, y1 is a1 sine omega t and y2 is a2 sine omega t plus phi, and just open the second function. Y1 is equal to a1 sine omega t plus a2 sine omega t cos phi plus a2 cos omega t sin phi. If you take common from the first two terms, the common is sin omega t, so inside the bracket you will get a1 plus a2 cos phi into sin omega t plus a2 sin phi into cos omega t. You can see in these two brackets whatever terms we are having, these are constants. If you replace them, let a1 plus a2 cos phi is equal to a cos theta and a2 sin phi is equal to a sin theta, where a is amplitude of resultant wave and theta is its phase difference. Then y is equal to, let us consider these two as equation 1 and equation 2. Then y is equal to a cos theta sin omega t plus a sin theta cos omega t. If you see, a can be taken as common. We will write a common cos theta sin omega t plus sin theta cos omega t. If we use formula of sin a plus b, then this term can be expressed in terms of y is equal to a sin omega t plus theta. So this is the equation of resultant wave, and this equation is also this is the equation of resultant wave, and this equation is also in the form of the two equations we have taken initially to understand the concept of interference. So y1 is a1 sin omega t and y2 is a2 sin omega t plus phi, and this equation y is equal to a sin omega t plus theta. So here a is amplitude. So to find amplitude, we will use equation first and second. The first square plus second square will give us a1 plus a2 cos phi whole square, a1 plus a2 cos phi whole square plus a2 sin phi whole square is equal to a square cos square theta plus a square sin square theta. If we open this brackets, it will be a1 square plus a2 square cos square phi plus 2a1 a2 cos phi plus a2 square sin square phi is equal to a square. Common on right hand side, so inside the bracket you will have cos square theta plus sin square theta. So a1 square plus a2 square cos square phi plus sin square phi. We have taken a2 square common plus 2a1 a2 cos phi is equal to a square, because sin square theta plus cos square theta is 1. If we use the same identity here also, we will get a1 square plus a2 square plus 2a1 a2 cos phi is equal to a square. It means a is equal to under root a1 square plus a2 square plus 2a1 a2 cos phi. So this is the equation of amplitude of the resultant wave. Then we can find phase difference also. To find the phase difference, we will use these two equations again. So equation second divide by equation 1. If you divide them, you will get a sin theta upon a cos theta is equal to a2 sin phi upon a1 plus a2 cos phi. Capital is cancelled, so you will get sin theta upon cos theta, and sin theta upon cos theta is tan theta is equal to a2 sin phi upon a1 plus a2 cos phi. By using this formula, we can find the phase difference between the resultant wave and the first wave, which is having zero phase. Now we have to understand under what condition the constructive interference will occur and under what condition destructive interference will occur. So first we will take constructive interference. To understand this, we have for resultant wave amplitude A is equal to A1 square plus A2 square plus 2A1 A2 cos phi under root. A is equal to A1 square plus A2 square plus 2A1 A2 cos phi under root. If phi is equal to 2n pi, then cos phi is equal to plus 1. You know that the value of cos is 1 if the pi is even multiple or integral multiple of even numbers. So phi is equal to 2n pi, n will start from 0, 1, 2, 3 and so on. If you put n is equal to 0, it will be phi is equal to 0 and cos phi is plus 1. If you put n is equal to 1, it is 2 pi and cos 2 pi is also 1. If you put n is equal to 2, it is 4 pi and 4 pi is also 1. So in that way, for all the values of this n is equal to 0 to 1 to 3 and so on, the value of cos phi is plus 1. Then A is equal to under root A1 square plus A2 square plus 2A1 A2 cos phi. Cos phi is 1, so we can replace for A is equal to under root A1 square plus A2 square plus 2A1 A2 into 1, because we have taken cos phi is equal to plus 1. Then A would be equal to under root A1 square plus A2 square plus 2A1 A2. So this can be written as under root A1 plus A2 whole square. If you take out the root, it will be a1 plus a2. So this amplitude is maximum. So a maximum is equal to a1 plus a2. So you can see, because we have the idea of constructive interference is the interference in which the amplitude becomes maximum. So this is the condition for constructive interference. Is a maximum is equal to a1 plus a2 and cos phi is equal to plus 1, phi is equal to 2n pi. So if phi is equal to 2n pi, the interference would be constructive. Similarly, discuss for destructive interference also. Again, we will use a is equal to under root a1 square plus a2 square plus 2 a1 a2 cos phi, and we know that the destructive interference results in minimum amplitude of the resultant wave, and it is possible if cos phi is equal to -1, that is phi is equal to 2n plus 1 into pi. So odd multiples of pi will give us a is equal to under root a1 square plus a2 square plus 2 a1 a2 into -1, which implies a is equal to a1 square plus a2 square minus 2a1 a2. So it comes to a1 minus a2 whole square. That gives us a is equal to a1 minus a2. So this amplitude is minimum, and at these places destructive interference will occur. So condition for destructive interference is cos phi is equal to -1 and phi is equal to 2n plus 1 into pi. In this condition, a minimum would be a1 minus a2. In this video lecture, we try to understand about the mathematical concept of interference, how the two waves are dealt mathematically to understand about the interference, what is the amplitude of resultant wave, what is the phase difference of resultant wave, and what are the conditions of constructive and destructive interference. I hope you will learn through this video lecture and try to understand the concept. If you have not subscribed this channel, subscribe it. Press the bell icon button to be notified for every new video lecture. Thanks for watching. Keep watching, keep learning.